Well, hello there, friend. We are going to do our third video for the June 2017 Algebra 2 Common Core exam. This will cover problems 17 through, I don't know, maybe 24, something like that. And, 17, 18, 19, 20, 21, 22, 23, 24, eight questions. All right? I had to count on my fingers in case you couldn't see that. Let's go. Let's get started. Let's do this poo-poo. First question really deals with data and stats. It's algebra. The orange highlight is algebra. This really deals with parabolas and directrix and focus and the whole 9 yards and the vertex form of an equation of a parabola. So 17 says a parabola has its focus at 1, 2. Okay, the coordinate 1, 2. And its directrix when y equals -2. The equation for the parabola could be, first thing you need to know is between the focus, the directrix, and the vertex. If you know any two of those three, the focus, the directrix, and the vertex of the parabola, okay, if you know any two, you can always find the third one. They give us the focus and directrix, so I can find the vertex because the vertex is always exactly in between the focus and the directrix. So I'm just going to sketch this, and I like visuals. It helps me. And if it helps you, then take the extra 2 seconds and sketch it. All right? -1, -2. My directrix is at y equals -2. So this line here, boom. That's y equals -2. That is my directrix. All right? My focus is at 1, 2. All right, so my focus is at 1, 2. That's the coordinate right here, 1, 2. All right, my vertex is exactly in between there. If you notice, okay, the point 1, 0 is exactly between because I go up 2 and I go down 2. Okay? I'm exactly in between. So that's how I know where my vertex of the parabola is. My parabola, if I had to draw it, never crosses the red line here I drew for the directrix. My focus is always inside the parabola cup. So my parabola would kind of look like this. I don't know exactly, but that's a good, an estimate, some sort of idea of what the parabola would look like. So right now, I'm going to take my vertex and determine which one of these equations could possibly be the answer. It's going to help me eliminate some choices here. 1, 2, 3, and 4, they are the vertex form of a parabola, meaning, all right, the vertex is in the equation. Technically, I'm adding nothing to the outside of each one of these, so I can put +0. All right, now my vertex, let's look at choice 2, is right here, the 1 and the 0. Keep in mind, anything inside parentheses always needs to flip. So that should be -1. Okay? This on the outside stays the same. All right? So I know my vertex is 1, 0. It is not -1, 0. Okay, so I know it can't be this. If I look at choice 1, this should flip as well. It's -1, 0. Okay, it's not this one. I look at 3, okay, well, this should flip and become a +1 and 0. So this is a possibility. And as I look at 4, this should flip out and become a +1 and a 0. Okay, so it's between 3 and 4 right now. And that's simply from knowing the vertex. Okay? So I'm just going to get rid of this poo-poo. Gone. These are bye-bye. I don't care about them anymore. Bye-bye-bye. Bye-bye. Gone. So the last thing I need to know is I look at the difference between 3 and 4. And the only difference between 3 and 4 is my A value. All right? That is the A value. How do I come up with the A value? My A value, when I taught this, there is an expression, a fraction, 1/4c. The thing is, you need to know what is the C value. That C value is the distance from your vertex to your focus. Okay, in this case, we are going up 2, so it's positive 2. If it were below, it would be a minus 2. But this is my distance of positive 2. So C is 2. And that means my A value is 1/8. The choice is 4. Okay, the choice is 4. Just a little bit of extra information if you ever come across where you have to graph this. This value down here, this denominator, that's also called the focal width. That is the width at the focus. That means the distance from here to here is 8. That means it would go 4 this way and 4 this way. All right? That you really don't need for the problem, but I saw an opportunity to explain something else about parabolas, and I gave it to you. But you definitely need to know this right here, 1/4C, that's your A value. And C is your distance from your vertex to your focus. Pretty good. Now, 18 is a data or an exponential. This happens to be an exponential. Okay, the function P of t equals 110e to the 0.03922t. That models a population of a city in millions. T years after 2019. Or excuse me, T years after 2010. Yeah, this is the year 2019, okay? As of today, consider the following two options. So as of today, meaning in 2019, consider the following two options here. The current population is 110 million, or the population increases continuously by approximately 3.9% per year. Okay, first of all, I see this equation and I immediately think APERT. That is an alternative equation for growth and decay. You are used to seeing this. Okay, but if something has a percent that is constantly or continuously being applied, okay, you need to do it like this, where this is your rate. You take this rate and it just becomes here. You multiply it times time. This is still your initial amount. This is still your ending amount. So this is your ending amount. This is your beginning amount. Okay, is your big P. Now, and T is time. R is still your rate. E is a number. Don't look. It is not a variable. Don't look for a value to put into E. E is 2.718, etc. It's in your calculator. So I look at this and I say, okay, here we go. I know my beginning amount is 110 million. That's my beginning amount. That's in the year 2010 when we start this, okay? Time, that's the years since 2010. So if today is 2019, this year, time would be 9, right? Because that's 9 years. Your ending amount, I'd have to calculate that. And my rate, this is my rate, okay? My rate is 0.03922. But if I converted that to a decimal, that's 3.922%. The two choices here are the current population is 110 million. No, that is not true. That is the beginning. Okay, in 2010, the population. This applies into, yeah, I'll be okay. Not 210. In 2010, my population is 110 million. They're asking me as of today. Okay, my board is stroking out, I'm sorry. As of today. No, as of today, the population is not 110 million. In 2010 it was. So it is not number one. Number two, so anything with a number one can't be an answer. 2 says the population increases continuously by approximately 3.9%. Yeah, absolutely, that is true. Ding, 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 ding. So it is only 2. On to number 19, straight algebra. And I just recalibrated my board, so hopefully it's done stroking out. To solve 2x over x minus 2 minus 11 over x equals 8 over x squared minus 2x. Ren multiplied both sides by the least common denominator. Which statement is true? Okay, all these statements talk about an extraneous solution. Okay, 2 is an extraneous solution. 7 over 2 is an extraneous solution. 0 and 2 are both extraneous solutions. Or this equation does not have any extraneous solutions. First of all, what does an extraneous solution mean? An extraneous solution is a solution that we can algebraically come up with. But when we go to check it, it does not work. Okay, it is very common when we are solving things that have square roots in them. Okay, but sometimes you have a fraction and you come up with an answer that doesn't work. How come? Because it might make the bottom of a fraction equal to 0. So for example, as I look at what I originally am given right here, if I had x equaling 0, let's say x equals 0. If I put a 0 in for this x, the bottom of that fraction would be 0, 11 over 0. That's undefined. It would not work. 0 would be an extraneous solution. If we work this problem out and get an answer of 0, that's extraneous because it doesn't work. What about if it's 2? Okay, if I put a 2 here, that would work for this x. But what if I put a 2 here? 2 minus 2 is 0. I would still get an undefined fraction. And if I end up with 2 as an answer, okay, that would be an extraneous solution. But ultimately, what I need to do is I need to solve this and come up with the answers. And then I can pick my choice. Because maybe 2 isn't an answer. Maybe the answer to this problem is 1 and 6. Then that means, and they both would work, I would pick this. I don't know if that's the answer. We're going to have to do this algebraically. So let's go ahead and start. All right? And I'm just going to rewrite everything here. I have 2x over x minus 2. Okay? The whole key is I want to get my denominators the same. Okay? And that means I'm going to factor each denominator. I cannot factor x minus 2 here. That's as good as it's going to get. Minus 11 over x. I cannot factor x anymore. That's going to just be an x down there. Equals 8 all over. Okay. I can factor this. I can pull an x out. And what's left would give me x minus 2. I just factored this. Now, if I look at all these denominators, okay, I look at this, and this, and this. I notice they all, everything in the bottom is either an x or an x minus 2. Okay? So why don't I make sure that every fraction has a denominator that has both an x and an x minus 2? All right? So I have an x minus 2 here. I just need an x. What I do to the bottom, I must do to the top. The middle fraction has an x, but it does not have an x minus 2. So why don't I multiply it? Now it does. What I do to the bottom, I have to do to the top. And the fraction on the right already has both. I need to do nothing to it. Okay? And the great thing about adding and subtracting fractions and equations is if all the bottoms are the same, I can just wipe them out. Yes, that was a kung fu noise. And I tell my students that when I walk in and I come to observe when they're taking the final, see if anyone, if there's any issues I need to deal with, I expect to hear some what-us happen in there because then I know they're canceling out the bottoms of fractions. So let's clean this whole thing up. Let's do our multiplication. X times 2x, 2x squared. This is not just 11 times. You don't forget that minus sign is being distributed. So negative 11 times x is negative 11x. Negative 11 times negative 2 is positive 22. Equals, I just have 8 over here. Oh, screams. Just screams quadratic equation. All right? Let's bring our 8 over. We got to set it equal to 0 and solve. Badoosh. I've got 2x squared minus 11x plus 15 equals 0. Okay? I tell my kids to do slip and slide at this point where I slip the 2 out back. But I'm just going to do kind of a guess and check. All right? I know that I have 2x times 1x. That gives me my 2x squared. So what multiplies to be 15? That should be 14, shouldn't it? 22 minus 8 is 14. Math teacher didn't know math. Plus 14, okay? All right, and I know it's really 1 and 14 or 2 times 7. 7 gives me 11, 4 and 7, so okay, here what it goes. I have a minus 7 and a minus 2 equals 0, okay? Those are my two booty cheeks, so to speak, all right? Now, T-bone, I solve each one of these. X equals 2, okay? This one, if I have 2x minus 7 equals 0, I add 7, and then I divide by 2. So x equals 7 halves. Here's the thing. The number 2, if I try putting 2 in this equation, we already said this bottom would be 0. 2 is an extraneous solution. This will not work. If I put 7 halves in, it will work. There is no fraction that would become undefined with 7 halves. So when I look at my answers here, which statement is true? 2 is an extraneous solution, okay? You have to figure out what your solutions are. You cannot have an extraneous solution unless at first it is a solution to the problem, okay? Notice 0 would not work, but 0 was never a solution. So it can't be an extraneous solution, okay? A little bit of work, but not too bad. Oh, right. One of the miscellaneous ones. You could, I suppose, categorize this under algebra, but it has to do with sequences, which are like oddball things in my mind. Maybe it's just my personal opinion. Let me drink some coffee. So, given f of 9 equals negative 2, which function can be used to generate the sequence negative 8, negative 7.25, negative 6.5, negative 5.75, etc. All right, this to me is an arithmetic sequence. How do I know that? Because the values change by the same amount. They're not being multiplied by some value as I go from one element to the next element. They are being altered by the same value. What do I mean? Let me rewrite this. Negative 8, negative 7.25. Negative 6.5, negative 5.75, and so forth. Okay. The difference between negative 8 and negative 7.25 is if I add 0.75, okay? But that's the same thing. If I add 0.75 to this value, I will get this value. If I add 0.75 to this value, I'll get this one. 0.75 is known as the common difference, okay? And we can come up with a sequence, and we can come up with a function, actually, using a little formula here. I take my first term, and I add to it my common difference times n minus 1. Okay? It doesn't matter if I put my common difference in front or in the back. It don't matter. I'm just putting it in the back, all right? This will always stay n minus 1, okay? You notice there's an n in every equation here, all right? So that n is my variable. My first element in my list is negative 8. Plus, this stays n minus 1. And my common difference is 0.75. So my equation, my function with a variable n in it, is this right here. I don't see that. You might be quick to say, oh, 2, but please, friends, this is a plus sign here. This is a minus sign right here. They are not the same, so it is not number 2, okay? So what I tell my students when we did this in class for the lesson, and if you want to go back, I don't even know, unit 1, I'm going to distribute this 0.75, all right? So let's do this. So let's take a look. I got negative 8 plus 0.75n minus 0.75. I can actually combine these two values because neither of them have a variable. Negative 8.75 plus 0.75n. right there. Choice 3. Perfect. All right? So that's my answer. How could I have done this? Like Visca, man, out of all the things I got to remember, this equation right here, I would have never remembered. All right? Look it. You can do this in the calculator. What you can do is the following. And I'm going to... Bam. All right, let me get rid of this. All right? You could have done this in the calculator one really easy way. All right? Which function can be used to generate? If I put this into y1, I look at my table. Be careful. This isn't 0, this isn't 1 and 2. Be careful. On your table, your first element, when x is 1, this should be your y. Okay? Not as you don't start at 0 with these sequences. You start at 1. When x is 2, your y should be negative 7.25. When x is 3, y should be negative 6.5. This one right here is the only one that's like that. I guarantee you, one of those equations will have this a 0x, you'd get this. This a 1. You would see this pattern and be like, oh, it's right. No, it's not right in this case. It's only right when your x is 1. That's where you start with your negative 8. So be careful. 21 takes a very simple math concept and puts a very complicated equation in there, but you just use your calculator to do all the math, okay? This one isn't really bad. It just takes a little bit more typing in the calculator. Number 21 states the function f of x equals 2 raised to the negative 0.25x times sine of pi over 2x represents a damped sound wave function. Who cares what it represents in this context? What's the average rate of change? Rate of change is the same thing as slope, which is the same thing as change in y over change in x, which is basically y2 minus y1 over x2 minus x1. That's all you're doing, okay? The average rate of change for this function in this interval from negative 7 to 7. These are both x values, okay? From when x is negative 7 to when x is 7. So what they did, in fact, let me write it this way. What they did is they gave us, when x is 7, we need a y, don't we? And they said when x is negative 7, we just need to find our y's. Okay, let's call these ones x2 and y2, x1 and y1, because ultimately we got to put them in this equation. Okay, so how do we get the y's when we already have the x's? I don't know. You can either plug 7 into this x, and get your y, or I can put this equation in y1 and look at my table, okay, which is what I'll probably do. In fact, if they want to go to the nearest hundredth, okay, I'll probably go out at least a couple more decimal places because I'm going to have to round. I'll probably go out 4 decimal places. So let's take a look at our calculator here, and let's put in our damped sound wave here. We'll go to y equals, clear this out, and I'm going to put 2 raised to the negative 0.25x times the sine of, we have a fraction here, I'm going to type it in just like they gave it to us. Okay, that's pi, and there is a pi here. Don't put 3.14, actually use pi. Pi over 2 x, right there, parentheses. All right? Now, if I look at my table, okay, oh, let's change our table. Table set. We're going to start at 0 and go by ones. Sorry. Table. Here we go. What about when x is negative 7? Okay, when x is negative 7, I get 3.3636. Okay, and now I need when x is 7. So I'm going to go scroll back down. Here we go. If I hold it, it does this toggle thing, which I can't stand. It should just hold that down. Let's go. Keep going down to 7. Where the hell are you? Bang, bang, bang. Okay, it's negative. Oh, it is negative. Okay, right there. 2. When x is 7, I get negative 0.2973. My board is stroking out. And when x is -7, I get 3.3636. All right, so let me get rid of these things. Bang, cut. Bada boom, bada bing. Hustler, baby. All right, so now all I'm going to do is put these in my change in y and change in x. y2 is -0.2973 minus y1, which is 3.3636, all over x2, 7 minus x1, -7. And if you do that in your calculator to right, you should get -0.26. No, I should do it in the calculator because I would expect you guys to. Let's use our fraction, okay? Let's use that fraction, and we are going to put those in just as we have them. -0.2973 minus 3.3636 all over 7 minus a -7. Hit enter. There it is, -0.261. And they want that to the nearest hundredth. That will stay a 6 because the number after it is less than 5. Bam, choice 3. 22. I don't like 22 for an Algebra 2 problem. It's really an Algebra 1 problem. Okay? Mallory wants to buy a new window air conditioner unit. Air conditioning unit? Yeah, that's what it says. The cost for the unit is $329. She plans to run the unit 3 months out of the year for an annual operating cost of $108.78. Which function models the cost per year over the lifetime of the unit? C of n, in terms of n being the number of years. So they want the cost per year. I don't care. Okay, well, before I get to the second part, our cost, let's list what our costs are. First of all, it's $329.99 for this thing. That is going to be a cost no matter how much we run, how many years we have it. That air conditioning unit is going to cost $329 just to buy it. It's part of our cost. The thing that's going to vary is the annual operating cost is $108.78, okay? Now, I don't care that she runs it 3 months out of the year. They want to know the cost per year. The annual, which means per year, cost is $108.78. So if I'm going to write something, excuse me, to figure out the cost of this thing for n years, I am going to pay $329.99 even without running it. That is just a constant cost. Boom, it's there. I will add to that. Well, it depends how many years I run this thing. If I run it for 1 year, I take this annual cost and I multiply it times 1, right? If I run it for 2 years, I take this cost and I multiply it times 2. 3 years, I would multiply it times 3 and so forth. So I take my 108.78 and I multiply it times my number of years. Number of years is n. And that's your equation right there. Bam. Badoosh. So this one, no. This one, no. It's crazy. So what's the deal with this? If I take my 108.78, and for some reason I see this number 3 and I multiply it by 3, this is what I'll get. They're trying to throw you off, okay? You just got to understand the cost per year. And your annual cost is 108.78. Okay, that is not a monthly cost. That is an annual cost. All right, that one was relatively easy. This is a good question. I want to say I don't like it because the answer is in a form they really tell you to never leave an answer in, which drives me crazy. All right, you can do the math. But then you got to do some algebra to clean up your answer at the end to make it look like one of their answers. All right. The expression -3 x squared minus 5x plus 2 all over x cubed plus 2x squared can be rewritten as. Obviously, I got to simplify this. Okay. There is a way to do this in the calculator. I will tell you afterward. But let's do this as if it were a short answer problem. Let's factor. First of all, I hate when my lead term is negative. I'm going to factor a -1 out of that. And I've got 3x squared minus 5x plus 2 all over. Well, the bottom here, I can definitely take out an x squared. That leaves me x plus 2. Now I know I've got a quadratic here. You can do slip and slide, which I would highly suggest if you didn't know what you're doing, or the m factor. The bottom is going to stay the same. But I'm going to do a guess and check. I know 3x times x is going to give me my 3x squared. Chances are, children, x plus 2 is going to cancel, which means 2 times 1 is 2 for the back. And if I FOIL that, I will absolutely get 3x squared minus 5x plus 2. All right? That is the factored form. So let's start canceling where we can. And the only thing I can cancel, oh. You see this right here is a negative 5? Oh, look what we did. I took a negative 1 out here, but I didn't take my negative 1 out here and here. This should be a plus 5 and a minus 2. What? Yes, plus, plus, minus, which changes things a bit for us here. That would be plus 5 minus 2. Okay. Let's redo this. Which means I'll have plus 2 minus 1. Okay, now we're good to go. All right. Let's take a look at this. Let's move that little cross hash thing out of the way. Badoosh. And now the only thing we can cancel is the following. Bang, bang. All right. So let's write what we have left here. We have, I'm going to distribute this just to get rid of it. It's negative 3x plus 1 over x squared. It's not an answer. Look what they do. Oh, yeah, it's 2. No, that should be plus 1 here. That's minus 1. Okay? So it's not 2. All right? So I'm taking a look at this. It looks like no other answers should work. But look what they do. Oh, I can't stand this. They break this up into 2 fractions. They say it's negative 3x over x squared plus 1 over x squared. They say, okay, I get that. Because if I combine these two, remember the bottoms stay the same and I just add the tops, it would end up back to this way. Okay? So, okay, we separated the fractions, which is something we really don't do too often. But then look what we do. They bring this x squared, okay, and they bring it up and negate the exponent. This x here can cancel with one of these x's, so I have x to the 1. They bring that x to the 1 up as well. Oh, so it's negative 3x to the negative 1 plus 1x to the negative 2. That's just dirty pool. If you ever have something like this, they expect you to make it into this. But they flip the script on you there. It can be rewritten technically as that. I can see some kids struggling at the end there. Okay, maybe not, the kids that really get it, but some that are struggling, I can see that's being very difficult. So I had mentioned that you can do this on the calculator. How so? I take this whole thing. I don't change a single bit of it. I put it in Y1. Okay? Then I put this in Y2 and I check, are the graphs the same? They would not be. I put this in a Y2. Are the graphs the same? No. Guess what? This one, if I put it in Y2, the graphs would be the same. All right? So anytime we only have one variable, okay, let me stress this. A lot of the time, when my one variable is just an x, right? Anytime, and the answers just have that. Okay, it's just the one variable. I can use a calculator, and it will help me if I get stuck. All right? Of course, a lot of my students do it this way. They say, can I pick a number and just put my number in for x? Okay, so let's say I say x equals, I always pick a random number, 7. Don't pick 0 or 1 because they don't have effect on certain math equations, okay? So take 7. If I put a 7 in for all these x's, one of these equations, if I put a 7 in for the x's, it will give you the same exact value. Okay, so you can do that as well. 24. I highlight this as data or exponential, and it kind of could be it could be miscellaneous. Anyways, Jasmine decides to put $100 in a saving account each month. The account pays 3% annual interest rate, compounded monthly. As soon as something is compounded more than once a year, we have a K value. K is 12. That's how many times a year your interest rate is compounded. In monthly, there's 12 a year. How much money will Jasmine have left after 1 year? This is also dirty pool in my mind because they never ask things like this. It drives me crazy. And I'll explain at the end. Now, first of all, if you're really bored, you can just add up all this money yourself and figure it out. But you could say to yourself, all right, well, here we go. Visca, I have 100 as my initial amount. It's 1 plus my rate over K times TK. All right, this is time in years. All right, and you can say to yourself, 100 is what she puts in. I have 100 times 1 plus 0.03, because that's my rate, over 12, okay, because that's my K value. My time is in 1 year times 12, okay, and you would get 100, 1.0025 times 12. And you would say, this is it. No, it is not. How come? This is putting $100 in and not touching it, not putting anything else in, okay? She's putting in $100 each month. This is just putting in one value of $100. Here she's putting in $100 12 times. So it is not going to be this, where you have an initial value and you leave it alone. Okay? It's going to be one of these two. These are the geometric series, and they are on, it is on the reference sheet. S of n equals your initial value minus your initial value times your r raised to your n, all over 1 minus r, okay? And don't forget that this r value, and it drives me crazy, is not just our rate, but it's our 1 plus our rate. And in this case, the reason I say they never ask us this, because this is always how it is, but see how it's compounded monthly? This is 1 plus our rate over K, which drives me crazy. They never throw anything that's not annual. They never throw in something that's compounded more than once into a geometric series, but they did it here. So my initial amount was $100 that we put in, minus the 100, it's the same value, right? Times my R, 1.0025 raised to 12, because that's my time, okay, 12 months, all over 1 minus 1.0025. That is dirty, dirty pool, but they did it to you. Wow, dirty. Visca, can I do this in the calculator? You would have to take $100, okay, add your interest to it for 1 month. Take that value, put another $100 in that. It would be complicated. So no, you're going to have to try and maybe, best of luck on this one. This one might be a guessing game. See ya for video 4, 25 to 31. You got it.